So this drill for this week then. So factorize this expression. So here's an expression. It's got in it two elements. So in that expression, no, that's two terms, and each term has got two elements in it. So this 5 is an element, and x is an element within that term. So there's two terms in this expression. And when I factorize something, I'm looking for a common element. It will be a number that's common to both of these. So x and y, remember, are numbers. They're not common because they're different. But we look for a number that might be common to both of these. Yes, 5 is common. 5 goes into 5 and 5 goes into 10. So I can remove 5 from a bracket. So when somebody says to you factorize something, what they're really saying is they want the bracket to appear, and you're going to try and remove a common element from each of the terms. So 5 goes into both of those. Can you see that? And then you say to yourself, right, what have I got to do to find out what's left in the bracket? What have I got to do to that 5 to get back to 5x? I've got to multiply by x. 5 times x gets me back to the 5x. What have I got to do to the 5 to get back to 10y? Times by 2y. So 5 times x gets me back to there. 5 times 2y gets me back to there. So going this way is called factorizing. Factorizing. Going from there back to there is called expanding. Expanding out the bracket to get back to there again. So that's the sort of terminology we use around these things. And whenever you factorize something, I would always recommend that you expand it, even if you only do it in your head, just to check it's right. Okay? Factorizing. You will be asked to do that in an assignment, and it does come in useful when you're trying to simplify expressions and turn a very long, awkward expression to something that is much easier to use. Okay. Number 2. 2/3 plus a quarter. What's the key thing to do here?
3 times 3.4.
No, that's not. And what you're doing, is it Sam? Oh, sorry, Daniel. Right. I think what you're doing is mixing up the idea of cross multiplying to make a common denominator, which is the right idea. But what we're after, find a common denominator. Yeah, which is right. How do I get a common denominator? Times them together. 3 times 4 is 12, so I can turn both of these into twelfths. How do I turn this into twelfths? What I do is, what have I got to times the 3 by to get 12? Answer, 4. So what do I do to the top? Times that by 4 too. Whatever I do to the top, I must do to the bottom. And then I've not changed the fraction. So long as I multiply top and bottom by 4, so 4 2s are 8, it's still 2/3, but expressed now as 8/12. What have I now got to do to make the 4 12 times by 3? So times the top by 3, 3 1s are 3. Now I've got a common denominator. I can add them. I can only add things that are the same. So we must make the bottom number the same. So I end up with some twelfths. So I never add the bottom numbers because that's just what I'm talking about. Add the 8 and the 3 and I get 11/12. Okay? That's important. Look at this. If I have to add algebraic terms like that, I can add them together only if there's a common denominator. What is the common denominator? xy. Good. Look at this. What was the common denominator here? Common denominator here, 3 times 4. So x and y are numbers. We just don't know what they are. So what's the common denominator? X times y. xy. So this becomes something over xy plus something over xy. Now the common denominator is there. So I can add them. And it will equal something over xy. Now the key thing now is, what have I got to do here? What have I got to times x by to get xy? So what do I do to the top? Times it by y. What goes in there? What goes in there? What have I got to times y by to get xy? Yeah. What have I got to times y by to get xy? Correct. So what do I do with the top? Good. To get. Right. So that's what goes there. Okay. So now, what goes here? 3y plus 2x. I can't go any further than that because I don't know what y and x are, but that expression now is the same as that. Okay. Oh, God, I knew I was going to do that. Why don't I just pick it up? Right, so that's that question. Next question. By the way, I'm zipping through them because I've got things I need to do today, but you know, if you want to stop or expand on anything, please just say. Next question, number 4. So we've got a formula. We spent some time last week using formula, plugging numbers into formula on the calculator and stuff like that, trying to get used to the buttons. So what I do in here is the area equals pi times the radius, which is 1.8 squared. That's literally what I type into the calculator, pressing the x squared button for the squared. Have I missed one?
You missed number 3.
Oh, right. Let's go back one.
No, it was
Oh, yeah. I did. Sorry. We'll come back to that then. So, number 3, 6.2 times 10 to the 3 over 1.9 times 10 to the 14. I want to spend a bit of time on this today. So, this number is in engineering notation. This number is in standard form. Now, those of you who've done work on engineering notation in standard form, why? Anybody can tell me? They go in threes. What does? Yeah, for the engineering notation, yeah. It must be in multiples of 3. So, standard form, in standard form, what's the key thing, somebody, for standard form, to convert a number to standard form? You don't. Exactly right. The decimal point must go after the first significant figure after the 1. So what we're talking about here, I'm going to expand on this, but let's have a look at it. What this number is 6,200. That number, 6.2 times 10 to the 3, is 6,200. What I've done is I've taken the decimal point, which is the 6,200, at the end of there, and I've moved it 1, 2, 3 places to there. And then I multiply it by 10 3 times to get it back again. So times 10 to the 3, or 1,000. That's a way of writing big and small numbers. I wouldn't want to write that. I've got to move the decimal point 14 places to the right on this one. So that would be a really big number. So this is a very convenient way of writing a large number like that. How do you put them into the calculator? The times 10 to is a button that you've got at the bottom of your calculator. Times 10 to the x, or if you've got an older version of the calculator, you'll have possibly EXP, which stands for the exponent. I can see that on yours. Okay. That allows you to put into the calculator times 10 to the. It should have gone round there. Times 10 to the. What answer? Anybody in the middle row, what answer did you get? 3.3 times 10 to the minus 11. Rounded? Did you round that? Yep, so what do you put at the end? To say that you've rounded it. Okay? Otherwise, somebody might quite rightly ask the question, is that an exact answer? No, it's not. You've rounded it, so you need to say that you rounded it, and that's how you do it. Okay? And that's an appropriate number of significant figures because there's 2 significant figures in the numbers you put in. So good. Okay, so more on that today. Next question we made a start on. So you key the numbers into the calculator literally as it says. If you've got these logical calculators, pi, the pi button, times 1.8 squared equals, Daniel, you had my calculator, didn't you?
10.178.
Unit? Daniel, unit?
Unit.
Look at the unit for the diameter. So what unit will this be?
Square.
What squared? Centimeters squared. Okay. Why did you say 10.178? Okay, so looking at it now, looking at the value you put in, what might you do with that now? Well, how many? What's the rule that we were talking about last week? Right, I can go to 1 significant figure more than the number I put in, all the same. So 2 or 3 significant figures. So Daniel, tell me what that is, 3 significant figures. 3 significant figures. 1, 2, 3. 10 point. If that's the right, because that's greater than 5 or greater. Okay, I was putting you under some pressure there, wasn't I, Daniel? Okay, 10.2. We were happy with that? I don't know why I've got all these extra pages in here. So next question, this density question. All right, guys. Focusing on this, I know you're talking about it, but you might miss something else that's coming along. Okay, you can always look back at it. So this one, density is mass over volume, is the formula. Density is mass per unit volume. That's the definition of density. And the unit of density would be grams per cubic centimetre or kilograms per cubic metre. You might see this written as grams centimetres to the -3 and kilograms meters to the -3. They mean the same thing. As we'll see when we come to laws of indices, a negative power here, and we'll talk about that a bit more today when we come to engineering notation again, means 1/, or the inverse of. So kilograms per cubic metre or kilograms meters to the -3. Note that the unit gives us a clue as to the unit, as to the formula rather. Grams per cubic centimetre. So if I measure the mass in grams and the volume in cubic centimetres, I've got grams per cubic centimetre. So that gives me the formula, or the formula gives me the unit, whichever way you want to remember it. Likewise, if I measure the mass in kilograms and the volume in cubic metres, I've got the density in kilograms per cubic metre. We don't mix them up and talk about kilograms per cubic centimetre or grams per cubic metre. We don't mix these units up. So, what's the problem here? No. I've got centimetres, cubes and kilograms, yes. So I've either got to convert cubic centimetres to cubic metres or kilograms to grams before I start. Okay? So which would you go? Which is the easiest to do? Okay. Kilograms to grams. So what is the number? 2.462 kilograms equals 2,462 grams. Okay. So now the density equals mass 2462 divided by 173. Now get my calculator out and work it out. So that was quite an awkward question because I threw that little curveball in there. Okay, 14.23 to 4 significant figures. And the unit? Right. So 14.23 grams per centimetres cubed to 4 significant figures. Good. Comments? What about if I decided to change cubic centimetres into cubic metres? Yeah. What do you mean by keep it the same? Yeah, you keep that in kilograms and then you... So how would you convert cubic centimetres to cubic metres? That's what I was asking really. Yeah. 0.173 because? No. 100 centimetres in a metre. Are there 100 cubic centimetres in a cubic metre?
1.73.
Yeah, no. Why not? Listen to this, Daniel. Right. If I want to convert cubic centimetres to cubic metres, I've got a problem because it's not a centimetre, it's not a metre, it's a cubic metre we're talking about. Sorry, I can't remember your name. Alan. And if you think about it, that's 100 by 100 by 100. So how many cubic centimetres are there in a cubic metre? How many cubic centimetres in a metre without using a calculator? What's 100 times 100 times 100? 1,000,000. Which is 10 to the 6. There's 10 to the 6 cubic centimetres in cubic metres. So to convert that to cubic metres, I would need to divide by 1,000,000. Which is not quite so straightforward, maybe as turning kilograms to grams. So, okay. A lot coming at you now, but you've got it on video and you've also got the link, so you can always go back and rethink about it. The next question, calculator question. So I'm going to spend a minute or two on this. This is an important skill to be able to use the buttons to get the answer in one hit on the calculator. Are we all right temperature-wise, by the way, or do you want a window open? You all right? Okay, so let's look at this then. So if you've not got these calculators, the buttons that I'm going to talk about now are not going to correspond to your calculator. You maybe got equivalent ones, I don't know. Let's look at this one first, because that's the easiest one to do. Hit the fraction button on your calculator. It looks like that. And then you can put 36.5 times 14.62 on the top and 36.5 plus 14.62 on the bottom, and then you directly get the total resistance. When we were talking about this last week, do you remember what to do if you've not got this fraction button? What's the pitfall? What might you do in error? Yeah, if you're trying to do it all in one, what have I got to make sure goes here at the bottom? Yeah, is that what you've got to make sure you do? You divide the top bit by all of this, so therefore you've got to put a bracket in. But if you've got the fraction button, you don't need to worry about that because it's just top over bottom. Okay? Answer? Unit? Ohms. Appropriate accuracy? Sorry, at the end there. Appropriate accuracy. Look at this answer. Is that appropriate?
No.
No, a bit too many, Daniel. A bit too many, aren't there? 5 significant figures you give me there. What would you give it then?
3.
3 significant figures? Okay, so what would that be? 10.4 ohms to 3 significant figures. Okay. Could have got away with 4, but not 5. Okay. Now, if we think about this for a second, this one here, what I've got to do is I've got to find the inverse of R1. What I'm after is 1 over 36.5 plus 1 over 14.62. Now I could use the fraction button and put 1 over plus 1 over. However, there is a button on the calculator that will do the inverse for you. And some calculators actually uses the button, on the button rather, is 1 over x to represent the inverse. But more commonly is this button, x to the minus 1. Because minus 1 means the inverse. The reciprocal, the inverse. So if I put a number in, like 1 over 3, and then hit x to the minus 1 on my calculator, I get what? Try it on your calculator. Put 1 divided by 3 in, or... Oh, no. No, it shouldn't be. 3. The answer should be 3. The inverse of 1 over 3 is 3. Right, yeah. Because if I flip 1 over 3 upside down, find the inverse of it, I get 3. Okay? Because 3 really means 3 whole ones, 3 over 1. So the inverse of 1 over 3 is 3 over 1, or 3 whole ones. Okay? So when I'm trying to find the inverse of something, I just hit that 1 over x button. So to do this on the calculator, this is what I would key in. I would key in 36.5 calculator. I'd key in 36.5 and then I'd hit the x to the minus 1 button, and on the screen you probably see 36.5 to the minus 1, which means the inverse. So can we do this on the calculator? 36.5, hit the inverse button. Plus 14.62, was it? Yeah. 14.62. Hit the inverse button, and the screen will probably say to the minus 1. Equals. And you'll get an answer. However, we are looking for 1 over the answer. In other words, the inverse of that. So, at this point, you hit the x to the minus 1 button again, because I want the inverse of the answer. And it will say, answer on the screen. And then hit the equals again, and you get 10.4. Blah, blah. Exactly the same answer as you got before. No? Try it again, Daniel. 36.5, hit x to the minus 1, plus 14.62, hit x to the minus 1, equals, and then x to the minus 1 of the answer, and you'll get it. So, yeah. Worked? Yeah. And you get exactly the same answer you get the other way. Okay? So that inverse button is useful if you want the inverse of whatever you put into the calculator. Okay. Comments?
Comment.
Yeah. Yeah, until you get used to the calculator. It's getting used to the calculator, isn't it? You're lost. What, on using the calculator? That looks a little bit of an older version. Yeah, so you won't have that. Right, okay. We've got two formulae that should give us the same answer. So if we use this bottom formula, just pause this. Okay, let's have a look at the next one. Averages, mean. How do you find the mean average? Yes. You add them all up and divide by the number r. That's a symbol for the mean, x bar. Add up all the numbers. How do I write that symbolically? Sum of. That symbol means the sum of. And fx. X stands for the numbers. Frequency stands for how many we've got. So if I had, say, added up 4 number 3s, 4 times 3 would give me 12, and so on. So this is how I'd represent, add up all the numbers. The sum of fx over however many numbers there are, the sum of the frequency. So that formula you will come across when you're looking up, if you've not done already, this stuff on statistics. So this symbol means the sum of. And it's a Greek letter, it's the Greek letter sigma. So if you didn't know that, make a note of it. Sigma, sigma fx. Capital sigma, actually. There's also a lowercase sigma, which we'll come across, and that's this. So that too is sigma, that 0 little line on it. We use the Greek alphabet to express things, because we run out of Roman alphabet, so we've gone on to the Greek alphabet, and we use all those symbols too. So all that means is add up all the numbers and divide by the number there are. Mode, most frequent, most common, most popular, most frequent. Median, yeah, middle value, assuming you've done what? Right, middle value when placed in order. In assignment 3, you're asked to find the median, the mode, and the median averages. Okay, so that's those questions. How did you get right? Add them up. Give yourself a score out of 7. I think it's out of 7, isn't it?